Good day everyone, my name is Babes Akanson and welcome back to my channel. And for today's video, I'm going to share my own example about integrating inverse trig function and integrating hyperbolic functions. Let's proceed to the first problem, which is how to integrate functions that leads to inverse trig functions. But let me remind you to memorize these three formulas for us to easily answer this kind of problem. Now let's work on this one example. What is the antiderivative of 3 over 25 plus x squared dx? So, our u squared is going to be x squared, which means u is equal to x. Du will be equal to dx. And a squared is 25, which means a is 5, the square root of 25. So what I'm going to do next is to move 3 to the front. Replace the dx with du, replace 25 with a squared, and replace x squared with u squared. So from the formula that we know, the antiderivative of du over a squared plus u squared is 1 over a arctan u over a plus c. Now that we have the constant in front, we've got to multiply this by 3. Next, let's replace a with 5 and u with x. So it's going to be 3 over 5 arctan u over a or x over 5 plus c. And so that's the solution for this problem. Next is we're going to talk about basic integration of hyperbolic functions. And we must familiar ourselves with formulas involving hyperbolic functions. We can see here that we have 8 formulas in integration of a basic integration of the hyperbolic function. So, might as well to take notes of these formulas. Let's start by integrating this problem. What is the integral of hyperbolic sine 1/2 x dx? As we can remember, if we look back at those formula from the previous slide, the integral of hyperbolic sine x ds is equivalent to hyperbolic cosine x plus c. We can see that there is no negative, whereas in trigonometric function, there should be a negative. But in a hyperbolic function, there is no negative. So as you can see here, we cannot directly integrate this hyperbolic into cosine of 1/2 x plus c. Why? Because our formula only tells us that this is the hyperbolic sine of x dx only. Okay, so what we have is to let u as 1/2 of x and du as 1/2 dx. So in other words, we will be using the u substitution. So again, we have du is 1/2 dx. As you can see our problem, it does not have 1/2. So we have to use a correction factor 1/2 here. And of course, the reciprocal of this correction factor outside the integral sign. So we have 2 integral of sine hyperbolic sine of u, which is 1/2 x, and then we have 1/2 dx, so that's equivalent to du. Now we can integrate this function. So if we integrate this function, we get 2 hyperbolic cosine of 1/2 x plus c. Again, we just let our u replace already by 1/2 x because originally our variables is in terms of x. So that is our answer.